Vanakkam, I am Sujit. Welcome to Physics 2020. So this is the fifth session in this topic, that is projectile motion in an inclined plane. So in the previous topics we have discussed the theory of that is projectile motion. So I have told you that in projectile motion in an inclined plane there are two types of projection. One that is from top to bottom, and another one is bottom to top. Okay, so we have discussed the theory of that is concepts of that is bottom to top, that is projectile motion in an inclined plane, that is from bottom to top or up down to top. Okay, down to top. So we have derived the we have what so the component vectors. Okay, we have found the component vectors, different component vectors, and we have derived the expression for time of flight, maximum height and horizontal range of a projectile, and we have solved some numericals in that topic. So today we are going to discuss the theory of that is from top to bottom in an inclined plane. Okay. So consider an inclined plane. Inclined plane of inclination theta. Clear? Inclination theta. So this is our x-axis. Okay, so the inclined plane will be taken as our x-axis, and this is our y-axis. Okay, so projectile is projected from here, from top to bottom, with initial velocity u at an angle alpha. At an angle alpha. So the trajectory of the projectile is like this. Okay, trajectory of the projectile is like this. Okay. So what are the different component vectors? That is in this direction. That is u cos alpha. U cos alpha. In this direction, u sin alpha. Okay, so G is acting in this direction, G. Okay, so what is the negative y-axis here? So that is the perpendicular to x-axis here. Okay, this is the perpendicular. So this angle is theta, this angle is 90 degree. So this angle is 90 minus theta. 90 minus theta. Definitely this angle is theta. Okay, theta. So this is G cos theta, and so the acceleration, this component is that is G sin theta. Okay, G sin theta. So the only difference is from bottom to top and top to bottom. That is the horizontal acceleration. Okay, horizontal acceleration. So the vertical acceleration is like this, as that of the previous case. Okay, it is same. But the horizontal acceleration, it is in that case, that is it is a deceleration. Okay, deceleration, that is minus G sin theta. So it is acting in the direction of that is the velocity u cos alpha. So the initial velocity is acting in this direction. So G sin theta is acting in this direction. So in the previous case, g sin theta is acting, that is opposite to the direction of the velocity. Just to remember the formula, that is, I will show you, that is in the previous case, suppose if you draw the diagram of x-axis and y-axis, so this is x-axis and this is y-axis. So okay, a projectile is projected from here with initial velocity u. So this is the trajectory of the projectile. Okay, so with the angle alpha. Okay, angle alpha. So this is what? U cos alpha. Okay, so this component is, it is u sin alpha. Okay, u sin alpha. This is g cos theta, and the horizontal acceleration is acting, that is g sin theta in this case, in this direction. It is in the previous case. So a projectile is projected from bottom to top. Okay, this is the case of bottom to top. Bottom to top. Okay, in the second video, that is the first video. Okay, so the projectile motion in an inclined plane, first video we have discussed this. Okay, so this is the case of, that is bottom to top. So if it is top to bottom means, so top to bottom, okay, top to bottom means the vertical acceleration is in this direction only, but the horizontal acceleration is not in this direction. It is in the direction of the velocity, that is g sin theta. It is the only difference. Okay, so g sin theta is acting opposite to that of velocity. So here g sin theta is acting in the direction of velocity, very very important. So in, that is from projectile is projected from top to bottom. Okay, come on, now that is the motion of the projectile, that is the combined motion, that is vertical motion as well as horizontal motion. Okay, horizontal motion. So we can analyze this, that is x and y. Okay, x and y. So what is the velocity in the x direction? That is u cos alpha. U cos alpha. So initial velocity, that is u cos alpha. So in the vertical direction, what is the initial velocity? That is u sin alpha. U sin alpha. So what is the acceleration in the x direction? That is g sin theta. G sin theta. That is positive only. Okay, plus g sin theta. So what is the vertical acceleration? That is minus g sin theta. Minus g sin theta. Okay. So these are the that is velocity and acceleration in the horizontal direction. X means horizontal direction, y means vertical direction. ठीक है? कदम. So now, what about time of flight? Time of flight. Time of flight, maximum height, and horizontal range. Horizontal range. So very very important, that is in time of flight and maximum height there is no change. No change. Very, very important. Okay. So whether the projectile is projected from bottom to up or top to bottom. So in time of flight and maximum height, there is no change. Okay, no change. That is the same formula you can use here. Okay, use here. So what is the time of flight? Okay. Time of flight, t is equal to time of flight. Time of flight, t is equal to 2u sin alpha divided by g cos theta. Okay, that is, so we can write that is 2uy divided by a ay. Okay, ay. That is 2 into, that is 2 times of the velocity in the y direction divided by acceleration in the y direction, that is g cos theta. Okay, g cos theta. So time of flight will not have any change. Okay, so t is equal to, what is the formula? T is equal to, don't forget that, t is equal to 2u sin alpha divided by g cos theta. So this is the formula for time of flight. So what is maximum height? So time of flight means, understand, that is time of flight. What is time of flight? The time taken by the projectile to make the complete motion. Okay, complete motion. So starting from here and reaches the ground. Okay, reaches the ground. So maximum height is nothing but from here. Okay, so this is the maximum height. So the maximum height attained by the projectile. Okay, projectile. H max, maximum height. So what is the formula? That is H max equal to u square sin square alpha divided by g cos theta. Okay, u square sin square alpha divided by 2g cos theta. Okay, 2g cos theta. So this is the formula for maximum height. So u square sin square alpha divided by 2g cos theta. Okay, so that's we can write, that is what, u y square divided by 2 ay. Okay, ay. So what is the meaning? That is velocity in the y direction square divided by 2 times of acceleration in the y direction. So the same formula we can apply. Okay, because the acceleration in the y direction has not changed. Okay, so the same component we are using. So h max equal to, what is the formula? H max. So you can write here, that is h max h max is equal to u square sin square alpha divided by 2g cos theta. Okay, cos theta. So this is maximum height. So what about horizontal range? Horizontal range, we have to derive the formula. Okay, horizontal range. So horizontal range means, so this is the horizontal range. Horizontal distance covered from the start to the end of the projectile. So how much distance it has traveled in the horizontal direction. So in this diagram, what is the horizontal range? So this much distance is the horizontal range. Horizontal range, that is R. Okay. So motion in the x direction. Motion in the x direction. Yes. I am using the equation, that is S is equal to Okay, so S is equal to ut plus half at square. So Sx equal to uxt plus half axt square. Okay, so what is Sx? That is the range. Okay, range r is equal to ux, velocity in the x direction, that is u cos alpha into t, that is the time of flight, that is into 2u sin alpha divided by g cos theta plus half into acceleration in the x direction, that is g sin theta. Okay, g sin theta into t square into, okay, t square, that is 2u sin alpha divided by g cos theta the whole square. Okay, so solving this equation we have done in this topic, that is in the second video. Okay, second video we have solved this equation. So in that video, so that is instead of this plus we have that is minus. Okay, minus. So here we have plus. So in that equation, so what we have got, that is r is equal to, what is the final equation? R is equal to we got, that is r is equal to 2u square sin alpha divided by g cos square theta. Okay, g cos square theta into cos alpha plus theta. So this is the equation we derived. In that case, that is r is equal to 2u square sin alpha divided by g cos square theta into cos alpha plus theta. So here that is plus means we will get, what is the equation? That is, what is the equation? That is r is equal to, I am writing here, that is, so this equation is for, that is down to top. Okay, so we will get the equation, that is r is equal to 2u square sin alpha divided by g cos square theta into cos alpha minus theta. We will get into cos alpha minus theta. So this is the equation for the horizontal range. Okay, so this equation is for, that is top to down. Okay, top to down. So don't learn this. Okay, so no need to memorize this equation. That is the equation for horizontal range. R is equal to 2u square sin alpha divided by g cos square theta into cos alpha minus theta. No need to memorize this equation, but you have to memorize this, that is t is equal to 2u sin alpha divided by g cos theta and h max equal to u square sin square alpha divided by 2g cos theta. You should memorize these two formulae, but no need to memorize. So according to the situation, according to the problem, we will derive, that is we will use the equation only. Okay, S is equal to uxt plus half at square. So ux you should know, that is u cos alpha. T is the time of flight, we will use this equation. Okay, and ax, what is acceleration in the x direction, that is g sin theta into t, that is time of flight. So using these equations we will find the answer. So no need to find so the way, that is how we are using the equation and how to get the value you should know. Okay, so clear. So this is the theory about, that is from that is top to bottom. So fifth problem. So this is an inclined plane of, that is 37 degree. The velocity, that is 10 meter per second. 10 meter per second at an angle of, that is 53 degree. 53 degree. Okay. So find one, time of flight, 2, maximum height, 3, horizontal range. Horizontal range. Okay. So time of flight. What is the formula for time of flight? T is equal to 2u sin alpha divided by g cos theta. Okay, g cos theta. So this is theta. Okay, so this angle is, that is theta is equal to 37 degree and alpha is equal to 53 degree. So these are the two famous triangles. Okay, famous triangles. So 37 degree means, so this is 37 degree. It is 37 degree means, that is 3, 4, 5. The sides of this triangle is 3, 4, 5. Famous triangle. Okay. So 53 degree. Okay, 53 degree also, that's a famous triangle. So 53 degree. 53 degree. 53 degree means 4, 3, 5. Okay, 4, 3, 5. Right. So 37 means 3. Okay. Smaller angle, small side. Okay, 3, 4, 5. Okay, 53 degree means 4, 3, 5. Okay, 4, 3, 5. So that's equal to 2 into, what is u? That is 10 into sin alpha. Okay, sin alpha. Sin alpha means, so this is alpha. Okay. Alpha, this is theta. Okay, theta. Sin alpha, that is, sin alpha means opposite side by hypotenuse, that is 4 by 5. 4 by 5 divided by g, that is 10 into, what is cos theta? That is cos 37 degree. Okay, cos 37 degree. That is adjacent side by hypotenuse, that is 4 by 5. Okay, 4 by 5. So 4 by 5, 4 by 5 get cancelled, 10, 10 get cancelled. That's equal to, t is equal to 2 seconds. That is the answer. T is equal to 2 seconds. So time of flight is equal to 2 seconds. Okay, 2 seconds. So next 2. What do we have to find? That is maximum height. Maximum height. Okay, maximum height. So what is the trajectory of the projectile? So it will be like this. Okay. So maximum height. So this is the maximum height. Okay, maximum height. H max is equal to u square sin square alpha divided by 2g cos theta. So that's equal to u square, that is 100, 10 square into sin square alpha. So 4 opposite side by hypotenuse, that is 4 by 5 the whole square. Okay, divided by 2 into 10 into cos theta. Cos theta means 4 by 5. Okay, 4 by 5. Clear? 4 by 5. So this 4 by 5 and this one 4 by 5 get cancelled. Okay, 10 cancel, that is 10 times. Okay, 10 times. So 2, that is 5. Okay, 5. So that's equal to 5 into 4 by 5. So 5 get cancelled. That's equal to 4 meter. Okay, 4 meter. That is the maximum height. Maximum height. So that's equal to 4 meter. Okay, 4 meter. And third one, horizontal range. Horizontal range. What is horizontal range? So horizontal range is this much of distance. Okay, this distance is the horizontal range, capital R. So motion along the which direction? X direction we are considering. Okay, motion along X axis. So Sx is equal to uxt plus half ax t square. Okay, t square. So what is ux? U cos alpha. So this is u cos alpha and this is u sin alpha. Okay, u sin alpha. So ux, that is u cos alpha. Okay, cos alpha. So we can write here. So separately we can write here. That is ux equal to, okay, ux equal to u cos alpha. So that's equal to u. What is u? That is 10 into, what is cos alpha? That is 3 by 5. Okay, 3 by 5. So 5 to, that's equal to 6. Okay, 6 plus, so u cos alpha into t plus half ax. What is ax? That is g sin theta. Okay, g sin theta into t square. Okay, g sin theta. G sin theta. So that's equal to ax equal to acceleration in the x direction. Okay, so this direction. So what? That is g sin theta. G sin theta. Okay, so g sin theta is equal to 10 into, what is sin theta? So 3 by 5. Okay, opposite side by hypotenuse. So 3 by 5. So that's equal to 2 times that, that is also 6. Okay, 6. So substitute the values. That is u cos alpha. U cos alpha means 6 into t, time of flight. That is 2 seconds. Okay, 2 seconds. 6 into 2 plus half into g sin theta. What is the value of g sin theta? That is 6 into t square. That is 4. Okay, into 4. So that's equal to 12 plus, so 3 times 4 3s are 12. Okay, 12. So that's equal to 24. Okay, 24 meter is the horizontal range. Horizontal range. That is equal to 12 plus 12, that's equal to 24 meter. Clear? So sixth problem. So consider an inclined plane of inclination theta. Okay, so projectile is projected from here with initial velocity u at an angle alpha. Okay, alpha. So what is the, this is the question, what is the relation between theta and alpha such that it hits the inclined plane normally or at 90 degree. So the same problem we have solved in that is in the previous case, that is from bottom to top. Okay, bottom to top. So what is the relation between this theta and alpha, or what is the angle of projection? Okay, alpha, such that it hits the inclined plane normally. So here this is the condition. Okay, so this angle of inclination, that is 90 degree. So when it hits the inclined plane means we know that is the projectile motion, or projectile undergoes two types of velocity, horizontal velocity and vertical velocity. So when it hits the inclined plane, suppose if the target, that is a projectile, wants to hit the inclined plane normally, means that is it has only the vertical component of velocity. It has only vertical component of velocity, that is Vy is there, that is Vx. Okay, Vx equal to 0. Okay, Vx equal to 0, that is the condition. So then only the projectile will hit the inclined plane normally. Okay, normally. So using this condition we can find, that is Vx equal to, what is the formula? That is Vx equal to V is equal to U plus At. So I am using the kinematic equation, that is V is equal to U plus At. Okay, so by the vertical Vx equal to, that is Ux plus, that is Ax into T. So this term becomes 0, that is equal to Ux. What is Ux? That is U cos alpha. Okay, U cos alpha plus Ax, that is A sin theta, sorry, G sin theta. Okay, G sin theta into T. Okay, so T. So here U cos alpha, this is positive, and G sin theta, this is positive. This time of flight is also positive. So here U cos alpha is in this direction. Okay, U cos alpha, and G sin theta, what is the direction of G sin theta? G sin theta is also in this direction. Okay, G sin theta, that is the acceleration is in the direction of velocity, that is it is an accelerated motion. So accelerated motion means the final velocity cannot be 0. So this is impossible, that is the final velocity becomes 0, that is the velocity in the horizontal direction becomes 0, means it is impossible. Because the acceleration in the previous case, that is the acceleration is in the opposite direction, it is a decelerated motion. Okay, decelerated motion. So here so this is an inclined plane. Okay, inclined plane. Inclined plane of inclination theta. So from projected from here with initial velocity u at an angle alpha. Okay, so here that is, this is u cos alpha, u cos alpha. So what is the projectile? So it hits normally, because that is acceleration. This is the x-axis and this is the y-axis is this one. Okay, so that is G sin theta is acting in this direction. So this is G cos theta. Okay, G cos theta. So this axis is, that is U sin alpha. U sin alpha. So here that is the horizontal velocity becomes 0. Horizontal velocity in this case also, that is hitting the inclined plane normally, means the horizontal velocity is equal to 0. The horizontal velocity will become 0. Why? Because the velocity is acting in this direction, so but the acceleration is in the opposite direction. It is a decelerated motion. So there is a possibility, that is decelerated motion means, so it will go to a certain height, and since this deceleration, the body, the projectile hits the inclined plane normally. Okay, so, but here it's not like that. That is the u cos alpha, velocity is acting in this direction, acceleration is also in the direction of velocity. It is a accelerated motion. So accelerated motion means there is no possibility of, that is the horizontal component of velocity will become 0. So therefore, that is hitting the target, hitting the inclined plane normally is impossible here. Okay, impossible. That is very, very important. Hitting the target in this direction from top to bottom motion. So hitting the inclined plane normally is impossible because it is an accelerated motion. Clear?